Hi, my name is László Kozma. I am the coordinator of the BodenTypeDC project. The demand of data center capacity is constantly growing all over Europe, and at the same time, the minimization of their environmental impact is crucial. Reducing carbon footprint, lowering greenhouse gas emissions, saving energy wherever it's possible. Back in 2017, our international consortium has been awarded with funding from the European Union's Horizon 2020 program to build and validate a research data center facility to reach energy and cost efficiency levels which were never seen before. Our project was built on demonstrating a range of highly innovative engineering principles, and the aim was not only to test and validate a prototype, but also to justify that fully or in part our concept can be used in the future in most parts of Europe. With 3 years of hard work behind us, I am proud to say that we have achieved our goals. The measured results and the simulations proved that the energy efficiency of data centers can be significantly improved by using appropriate innovative technologies. I am also proud that we have demonstrated in our international project that collaboration between researchers and business people can lead to excellent professional achievements and at the same time to long-lasting cross-border friendships.
Hi, my name is BodenTypeDC and I'm the project manager of Work Package 2 on the BodenType Data Center project. Work Package 2 was responsible to design and build a prototype data center, the BTDC building and its services infrastructure, and operate and maintain this facility to allow the scientific tests to take place. Our idea was to design and build a data center facility that is energy efficient, quick to deploy, versatile and cost-effective so that it fits within the budget of the project. Energy and cost efficiency of the base services infrastructure was achieved by maximizing the benefits of the location, whilst minimizing the constraints such as the extreme cold weather. Fresh air was supplied directly to cool the server racks to benefit from the availability of free cooling. Adiabatic humidifiers provided further cooling during the warmer summer months, and were also used to humidify the incoming cold air during the winter. The primary and only power source was from locally produced renewable energy. Due to its reliability, neither generators nor UPSs were used to further reduce losses in the electrical system. As the speed of delivery of a newly built data center is one of the most important aspects, the building was designed with simplicity in mind. We used local building techniques, such as glue lamp frame, which was erected on the top of the reinforced concrete slab. The walls were made of composite sandwich panels and no raised floor was installed. In order to be flexible and scalable, the building was built from modules, or pods as we called them. These pods, which housed the IT equipment and the coolers, could be easily reconfigured to serve most type of IT hardware, with a broad range of IT load densities from, say, conventional OCP servers from 4 to 6 kW per rack to high-performance computing hardware with 50 to 100 kW per rack, all of which had been actually tested in the 3 pods of the BTDC building.
Hi, my name is Reinhard Herzog. I'm from the Fraunhofer Institute ISB and I worked on the workload management for the BodenTypeDC project. The single purpose of this project was to design the most energy efficient data center in the world, which we hope is this one. Efficiency for data centers, simply speaking, means to provide as much IT power as possible with as less facility cost as possible. So what we needed to test our design was to consume this IT power and to create some heat inside the facility. And that was done by our workload management. It produced a predictable and repeatable IT loads with very well-defined characteristics. And our workloads are composed of synthetic load applications. These one producing very stable loads, and also an emulation of real-world IT applications, which are much more noisy. And we also wanted to run these experiments in all the different seasonal climatic conditions. So what we did was to create a test week pattern, which was a combination of different workloads combined in one week that all created very specific utilization characteristics for this data center, like for example 80% CPU load for 1 hour, and then for some time an IoT applications like a predictive maintenance application. And this pattern was then repeated for the duration of 1 year every month. And this one produced all the data we needed to analyze if our data center is indeed the most energy efficient data center in the world.
Greetings! My name is Gábor Benke and I work for H1 Systems. In Work Package 4, we had the task to simulate and evaluate BTDC's behavior under different IT load patterns and different climate conditions. To do that, we used H1 Systems DC Sim software. This software is able to model the dynamic operation of the built environment and to determine its energy and water needs used for the operation. Moreover, it's capable of to calculate the cold air's temperature and humidity hour by hour. The code is written in JavaScript language and it integrates EcoCooling's mathematical model for cooling systems efficiency, psychometric equations describing adiabatic cooling, building energy, heat loss calculations. The simulation inputs are customizable. We can choose different IT load patterns and historical datasets from different cities and years back to 2017. After the simulation is done, using DC Sim's analyzing tool, we are able to choose resulting values and also variables to visualize and evaluate them in one graph. The simulation results were rather surprising. Accordingly, BTDC is feasible even in Madrid or in Athens.